Good morning students, that is EC 8553 discrete time signal processing. Here first of all we see about discrete Fourier transform unit 1. Here the first of all signal. What is a signal? A signal is defined as a physical quantity that varies with the time, space, temperature or any other independent or dependent variables. Okay. Yeah, signal is maybe defined as a function of one or more variable which conveys the information. This is the correct definition, easily understand. A signal is defined as a physical quantity, okay, with varies, that varies with time or space, temperature or any other independent or dependent. Otherwise, a signal is defined as a function of one or more variables which conveys the information. So that examples, it may be the radio signal or TV signal, telephone signals, etc. Okay, other signals also available. Then classification of signals: continuous time and discrete time signals, periodic and non-periodic, otherwise a aperiodic signal, even and odd signal, it can say symmetric and asymmetric, then energy and power signals, deterministic and random signals, causal and non-causal signals. First we see about continuous time signal. A signal x of t is said to be a continuous time signal if it is defined at every instant of time t. Right, the amplitude of the signal varies continuously with the time. Simply we can say amplitude of the signal varies continuously with the time. A continuous time signal also called as the analog signal, right. So examples: AC waveform, ECG, etc. Then now we move to the discrete time signal. A signal x of n is said to be a discrete time signal if it can be defined only at specific values of n. Okay. So example, amount that is deposited in a bank per month, for example, we can say, right. Then systems, signals already we know, just we go for the next systems. The system is defined as a physical device that can be generate a response or output signal for a given input signal. A system may be defined as a set of elements and functional blocks interconnected to produce an output in response to an input. Now see the block diagram. System can be represented by block diagram, and arrow entering the box is input signal or excitation. The arrow leaving from the box is output signal or response of the system. X of n, that is enter into the system, then finally we get the y of n. And the relationship between input and output signal is as follows: y of n equal to t of, that is a transfer function, t of x of n. T is the system transfer function, system function equal to output y of n divided by input x of n. The system is classified into 7 types. There are continuous time and discrete time system, static and dynamic, causal and non-causal system, linear and non-linear system, time invariant and time variant, stable and unstable system, recursive and non-recursive system also. Then basic elements of DSP, here the analog signal enter into the analog to digital converter, finally we get the digital signal. It is moved to the DSP processor, right. There is a system DSP processor. The output of the DSP processor is always the digital signal, then enter into the DAC, that is the digital to analog converter. Finally we get the result is analog signal. Here the Tudor factor function is available. The DFT of the sequence x of n of length n is given by x of k equal to summation n equal to 0 to n minus 1 x of n t power minus j 25 n k divided by n, that is k equal to 0 to 1 n minus 1. Then phase factor or Tudor factor Wn equal to e power minus j 2 pi bar n, x of k equal to summation n equal to 0 to n minus 1 x of n to Wn power n k. Okay. So next one, what is the zero padding? Appending zeros to a sequence in order to increase the size or length of the sequence is called zero padding. Here the what is the need for that zero padding? In circular convolution, when the two input sequence are different size, then they are converted to equal size by zero padding. What is the uses of that? Better display for the frequency spectrum and for the linear filtering. Thank you students.